In this example, we look into how you can retrieve data from online data services. And as an example, we'll just go here and pick some weather data. So we have the weather data plugin here. And as you can see here, it'll work by zip codes. So whenever you have a zip code that would like to look into, let's say temperatures, something like that, you can use this one. And it works in the way that you simply pick whatever country you would like to look into. For example, Germany here, and then you go and pick the zip code that you'll be interested in. You can add as many as you like. But if you have a longer list, you can also use the file option. Maybe you already created a small text file containing zip codes. Actually, I did it here. So it's this one here. It's just a very small text files with some US zip codes. These are actually the zip codes for the capitals of the 10 biggest states in the US. So let's just add those. Maybe you should give it a name here. I'll simply call it then weather for 10 states. And by going here, I can then select my zip codes text file right here. So now I'll pick those 10 zip codes from the United States, and I'll just save it. I notice that you can change the schedule here for how often you would like to update these data. And of course, also we'll need to go here and tell the system how many years of data, for example, we would like to retrieve. So 2 years of data in this case. So now we'll just be waiting for this one to actually create. This might take a couple of minutes. So now it's available, and if we go here and right click to preview the data, you can see that, well, we retrieve data from a number of stations. These are station numbers here. You get your zip codes. And if we look at a bit further on, you can see we got a lot of meteorological data, including temperatures, wind speed, dew points, etc. But for example, we got the temperatures. We also got the maximum temperatures and minimum temperatures in Celsius and Fahrenheit. So let's focus on those temperatures. Actually, those are the ones I would like to express in an analysis. But before I do that, I'll just add another small data source here. It's a small data source where we just log into these zip codes. What are the actual states and what are the actual capitals of those states? And that's the information you get here. So this one is just going to become a dimension table in your data model. So let's add it. It was a comma separated file. And we just need to browse to it, locate it. It's this one here. Okay, and that. And yeah, we just save it as it is here. That should be okay. So now we got that extra data source, our comma separated file and our weather data. So going back here, we can now create a new cube. Let's simply call it weather 10 states. Like this, and then go and add the data sources. So we got our fact table, the one containing the temperatures, and also we got our supporting dimension table, the one with the state and capital information. This one I just marked that as a fact table. I would probably go here. There are lots of information we don't need, so I'll start out by hiding everything and then just pick the things I need. So I'll need, of course, the observation date. That'll be interesting. And also you can set up your relation by the zip codes. So that was your key between those two tables. And furthermore, we need something related to temperatures. So we got the temperature in Celsius here, and temperature max in Celsius and temperature minimum in Celsius. Let's just go with those three measures. Furthermore, you might choose to simply include everything from your dimension table here, zip codes, states and capitals. That'll be okay. Over here in your fact table, the observation date should be a dimension only, and the three temperature measures, well, should not be a dimension, but should be actually an average measure. It's no use that you actually make a sum measure here, because you don't want to sum up 10 days of temperatures that'll give you 100 or 150 degrees Celsius. That doesn't make sense. So the average will be the right one. Over here, we got the zip codes, just as dimension. Everything actually is simply as dimensions like this. So let's just save this one. And, well, now we can just save the cube and wait for that. And once that has been saved and it's ready, we can close down the data modeler, and you should be able to see your new weather 10 states cube over here, from where we can pick these average measures, the temperatures, maximum and minimum. And we might want to look at this by your observation date. So we got it by years like this. Maybe this one should be turned into a line chart. So if we try that, we can expand your time dimension a bit further. And of course, as we are in the northern hemisphere, we can see that January is all the cold months, and June, July, August are the warm months. So going down all the way down to the date level, you get something like this. We can also add a cross tab where we look at those three measures by, let's just include the states, the capitals, and the zip codes. Those are actually three separate dimensions, but I can add them to the same axis here if you like. However, when I do it like this, I probably also want to go here to hide my subtotals to get something like this. So now we can use these data to analyze it, the weather data for these different states. So I'll just hide my panels here. So if we look at California, Sacramento, it's close to the water, so got a very uniform temperature across the whole year, as you can see here. While if we go for one of the northern states like Michigan here, of course it'll be considerably colder during the winter months, but also you can see the seasons much better up here.